Today we're going to learn about cone of vision. In perspective drawing, a viewer stands on a ground plane at the station point and sees the scene through the picture plane. This picture plane could essentially be your entire piece of paper, or it could be a part on the piece of paper like this. Just imagine it as being a piece of glass in front of you, similar to when you look outside of the window at a view. The window is our plane and the view would be our drawing. So when we want to draw something in perspective, we need this picture plane. So the viewer looks at the picture plane from the station point, and it pretty much represents the viewpoint where we would be looking at our object. This is the horizon line, and then we'll start by finding our center, vanishing, or focus point. This is the point in which we would be looking at in the scene. The vision of the viewer radiates out from the station point as a cone that ends at the picture plane. We call this the cone of vision because it's like a cone. Think of something like an ice cream cone. The cone of vision is our field of vision. This is usually a standard of 45 to 60 degrees, so anything that falls outside the cone of vision will technically be outside the viewer's field of vision and will start to look slightly distorted. To create the cone of vision in our perspective drawings, take a line from the station point up to the horizon line at a 30-degree angle. The easiest way to do this is to use a standard 30, 60, 90-degree triangle fixed at the station point. Next, we draw a circle around the 30-degree mark using the center vision point as the center of the circle. I'm using a compass here. The circle represents the cone of vision coming from the viewer's eye and hitting the picture plane. The inside of the circle is the optimal area for making our perspective look normal to our eye. We draw 30 degrees over to the right, 30 degrees to the left, and this cone of vision represents a 60 degrees. So, because the cone of vision sits at 30 degrees on either sides of the center vision, we call this a 60-degree cone of vision. So that's how we establish our cone of vision. To keep your perspective looking more true to human vision, stay inside the 60-degree cone of vision. The farther you go, the distortion continues to get more and more until it gets really unacceptable. This is the area that we can draw in comfortably without having to be too concerned about distortion. Everything right here at the center vision you will draw will be perfect, unless it's quite close to the edge. Again, here's the picture plane, and here's our station point, which is the viewer's eye if we look from above. Let's assume we have a series of circles here, all the same size. I'll put one in front of the viewer and the rest are farther. The person sees the first ball as a perfect circle and it's going to be totally round, but the rest of the balls have stretched out. They're going to look more like an ellipse than a ball. If this person standing here traces these balls on the picture plane, each of these balls will appear differently in his eyes, because the viewer's eye is hitting the picture plane at its oblique angle, so it's going to look something like this. This is even more stretched out. This is how wide each ball will be. So you can see that the farther away this person is from this piece of glass, the bigger the cone of vision will be. If you put the picture plane really close to the viewer, you have a really small cone of vision. Like if you're in a room and your face is really close to a wall, you can only see a little part of the wall. If you keep backing away, you can see more and more of the room. So this is what is happening here. The farther away you go, the more you can see. In the next tutorial, we'll have an example of this topic. We'll talk about how to draw a perfect square. And then after that, how to draw a perfect circle using a perfect square. Thank you so much for watching, and I'll see you guys in the next video.